Hi guys, let's take a look at this question. They give us two reactions of sulfuric acid, reaction 1 and reaction 2. They ask us to define a Lowry-Brownsted base. According to Lowry-Brownsted, a base is a proton acceptor. Then they want us to write a balanced equation for reaction 1. Okay, so we have sulfuric acid plus sodium hydroxide, and that will give me sodium sulfate plus water. Okay, now this is not balanced and I got to balance it. So what do? I start with hydrogen. Let's just start with hydrogen, right? There's 3 hydrogens on this side and there's 2 hydrogens on that side. Okay, so we already know the hydrogens must be fixed. I have 1 sulfur. The sulfur is perfect. I have 4 5 oxygens and I have 4 5 oxygens. Oxygens are perfect. Then I have 1 sodium. Oopsie, there's a mistake. Just forgot to write the 2 there because actually that changes everything. So I have one sodium here, but 2 sodiums there. So I want to also fix my sodium. So I can just add a 2 here. That will give me 2 sodiums and that will give me 2 sodiums. Then that is fixed. But now what happens? That changes my hydrogens and it changes my oxygens. Because now I have not only 4 oxygens, but I have 6 oxygens. All right. And I have 4 hydrogens. So simple solution here is to just add 2 in the front here. Because then that will give me also 4 hydrogens and 4 plus 2 times 1 is 2, 4 plus 2 is 6 oxygens. And that would be the balanced equation for reaction 1. 8.1.3. Write down the name of the salt represented by X. So the salt here we've already determined is sodium sulfate. So they want the name though, so it's sodium sulfate. Write down the formula of amphilite A. Amphilite A is here. So to get sulfuric acid, we would then have the amphilite of HSO4. Write down the formulae of the 2 conjugate acid-base pairs in reaction 2. So acid-base pairs, we have just established that it's HSO4 and sulfuric acid. Okay, and then also H2O and H3. Okay. Then 8.2. A solution of sodium hydroxide is prepared by dissolving 6 grams of solid sodium hydroxide in 500 centimeters cubed water. This solution reacts completely with 10 grams of impure ammonium chloride. And they give us the equation below. Calculate the concentration of sodium hydroxide solution. Okay, so they've given us the mass and they've given us the volume, and we can calculate the molar mass of sodium hydroxide. So, we have this formula because we want the concentration. The mass of sodium hydroxide is 6 grams. The volume they have given us is 500 centimeters. We want 0.5. And this is a capital M. The molar mass of sodium hydroxide, we just look at the periodic table. Sodium molar mass or sodium atomic mass plus 16 plus 1, and that should give you 40. And we put that into the calculator and we get 0.3 moles per decimeters. Sorry, I don't know why I wrote that far like there. So it's decimeters cubed. And that is the concentration. I'll see you in the next one.